Hello and welcome to Chapter 8, Network Infrastructure and Troubleshooting. So let's continue with networking. So let's talk about the first thing. The first thing we're going to talk about is the 7 layers of the Osi model and the 2 CPIP model. So first off the bat, before we continue, I want you to write all of this down. The table and the explanation of what port numbers, IP addresses, and MAC addresses are. As I discuss this, give me about 5 minutes. I'll go over it. You can pause and write this down. Or don't forget to upload whatever you're going to write down. So, in the late 1960s, early 1970s, the Department of Defense created an agency called ARPA, the Advanced Research Project Agency, and they came up with the TCP/IP model. The TCP/IP model says we are going to, anytime you want to send data, you got to go through 4 layers of encapsulating your data before it exits onto the wire, on the media. Now, later on, the ITU, the International Telecommunication Union, which is, it's a body for the whole world that discusses communications so that the whole world can communicate with each other. They wanted to do the same thing. So they took the TCP/IP model and broke it down into 7 layers instead of 4. And you need to remember those 7 layers. So this is how they actually did it. They took layer 4, broke it into 3. Layer 3 became 4. Layer 2, they changed the name from internet to from internet, they kept it internet. And the network access became here it's not internet. I'm sorry, I apologize. This is supposed to be network layer. All right. So, and the internet became the network layer. The network access broke it down into 2 layers, the data link and the physical. So the way to remember the OSI model, the 7 layers, is all people seem to need data processing: application, presentation, session, transport, network, data link, and physical. Physical is where you actually place the data on the wire. So your Ethernet NIC operates on the bottom 2. All of these data, as soon as you type an email using the SMTP protocol, so let's say you wrote an email, it goes according to the simple mail transfer protocol. Then that message becomes, we call that data. And then that data is given to TCP protocol, transmission control protocol. And what the TCP does, it breaks it up into segments, attaches port numbers to it. The port number identify what type of data was the segment in. So the port number for SMTP will be 25. So on each of the segment, when you take the data and break it up into pieces, on each piece, you're going to put port number 25 to identify that it's an email. If you did HTTP, the port number would be 80 on each of the segments. UDP takes DHCP or DNS, will send the data to UDP. They do the same thing. DHCP will put the port number like 69 or 68. So each of these applications has a specific port number that will be stamped at the transport layer to identify what type of application that's in there. Then the segments are passed to the IP protocol, and the IP protocol put the IP addresses on it. The IP addresses identify what network this packet is in. The host and the destination IP address identify the network that the user is in. So remember, we talked about that last time. The source IP address, you get that from the DHCP server. The destination IP address, you get that from the DNS server. Then the packet is given to your NIC. So all of this happens inside your PC software-wise before it exits and you give it to the Ethernet NIC. The NIC takes the packet, puts it into frames. Then you put the source MAC address on the frame. You get that from the NIC. And the destination IP address, you get that by sending out an ARP request, requesting the MAC address for everyone. All right, so please write this down. This is very important. If and when you do take another networking course, we'll be reviewing this over and over again. This is a fundamental for almost every networking course that you need to know. All right, moving on. So That's the 7 layers of the OSI model and the 4 layer of the TCP/IP models. So let's move on and talk about the IP addresses and how they are different. So this is, what is an IP address? An IP address, there are IP addresses, IPv4 and IPv6, all right? And the addresses and the MAC addresses are always converted into binaries. So here we go again. I'm going to show you an easy way. I want you to write this down. So an IPv4 and IPv6 address and the MAC addresses are always converted to binary before they are used by the digital device. So because digital devices only work with with binary numbers, high and low. So if we write the number 192, this is how it's converted to 192. So what you need to do to be able to convert binary, so all you got binary to decimal, so these numbers, 8 bits, 8 ones and zeros, you put them right under these numbers. Wherever you see a 1, you add it on the top. So if you want to convert 11000000 to decimal, you put 10000000 here, and wherever you see a 1, you add the numbers on the top. So I see 128 plus 64. I don't see any more 1s, so 128 and 64 is 192. If I want this number, 10101, that's 128 plus 32 plus 8, that's 168. If you want to go the other way around, what's the number 10? The number 10 is 8. You put a 1 here, and you put a 1 here. 8 plus 2 is 10, right? 3, all zeros, you just put 1 and 1, right? So for the IP address, when you type an IP address, 192.168.10.3, the device really converts it into this, right? All ones and zeros, 32 ones and zeros, 32 bits. The MAC address is written also in binary, by the way, and so is IPv6. But the problem with the MAC address and the IPv6, they're very large. Even if you want to write them in decimal, it'll still be too big. So we got to use what we call hexadecimal numbers. And in hexadecimal numbers, every 4 bits is converted into 1 digit. So here's the 0. By the way, it's 1, 2, 4, just like here. You remember 1, 2, 4, 8. That's how I can come up. Oops, sorry. That's how I can come up with these numbers. So for example, a 5 is 4 plus 1. A 6 is 4 plus 2. A 7 is 4 plus 2 plus 1. An 8 is just an 8 with the rest zeros, right? The thing with the hexadecimal is when you get past the 10, you don't write the number 10. 1, 0, 1, an 8 and a 2 is the letter A. And B is 11, C is 12, D is 13, E is 14, and F is 15. So if you want to convert C3, you just look up here. C is 1100, and 3 is 011, right? 011. And if you want to convert, go the other way, 101, 1001, 1111, that's a 9, the 1001, and the 111F, that's an F. All right, so therefore this MAC address, when you typed ipconfig, you'll remember, like this MAC address, this is, each one of those digits is 4 bits. So here's an example of a MAC address, and this is 48 bits, right? It converts to this. All right, here is, okay, so now let's talk about a subnet mask address. A subnet mask address, when you see an address written like this, the slash number is a mask. And it could be, this identifies that you have 24 ones. So you write 24 ones dot 20, I'm sorry, 8 ones dot 8 ones dot 8 ones dot 4 zeros. That's 255, 255, 255.0. That's slash 24. So the slash 24 identifies also that the first 24 bits, the first 24 numbers, this 8-bit number, this 8-bit number, this 8-bit number is the network portion of the IP. So this slash number is the mask, and the mask number identifies, is used to mask the host portion of the IP, which means that 3 is masked, which means we're making it 0. And to be able to reveal the network portion of the IP. Routers need to know that. Routers need to know what network the IP address is in. So the IP address contains two things, a network portion and a host portion. And the mask helps us find out what the network portion is. If you are inside on LAN, I want you to write this down too. I want you to write all of these down. All right? I want you to write down also what private IP addresses are. Private IP addresses are the IP addresses that are used inside a private LAN. You cannot use a private IP address to get on the internet. All right? Routers in the private LAN run a routing protocol called NAT, and NAT is used to convert the private IP address to a public one to get you on the internet. So if you are inside a LAN, most likely your IP address either begins with 10. XXS doesn't matter what the last digit numbers are, or 172.16 to 172.31, or 192.168. So if your IP address begins like that, most likely you have a private IP address, and you cannot use that to get on the internet. That when you send a packet to your default gateway is running a protocol called NAT. NAT will translate this private IP address, give you a public one to get on the internet. The public one is what the ISP gives to your modem. All right, you don't even see that. All right, now what happens if you turn your PC on and your PC does not find a DHCP server? Now, please write this down. It's also good for troubleshooting. If you do that, it will automatically configure itself with an APIPA. An APIPA stands for automatic private IP address. An APIPA address starts with the numbers 169.254.x.x. What does that mean? That means if you type ipconfig and you see this number 169.254.x.x, you know something is wrong with the DHCP server. That means the CCV receiver is down. And because when your PC went to look for a DHCP server, it wasn't there, it automatically created its own APIPA address. All right, so this number indicates that the DHCP number is down if your number starts with 169.254. All right. Remember, all hosts in the LAN must know what their default gateway is, right? The default gateway is the one that allows you to go outside in the LAN. If you don't have a default IP address, then you won't be able to get on the internet. Remember, get on the internet or go outside your LAN. There are three things that the DHCP server will give you when you turn your computer on. It'll give you the IP address, the subnet mask address, and the default gateway. All right, so an IPv6 address contains 128 bits, right? Very long. That's why we're never going to run out of IP addresses. Each of those digits is 4 bits. This number is written in hex. So if you convert each of those digits into 4 bits, you'll get 128 bits. All right? There are 4 types of addresses you should be familiar with, or 4 types of packets that a user can transmit. And please write this down. Number 1, Unicast, which means you are sending one packet to one host. Broadcast, when the user sends one packet to everybody in the LAN. Multicast is when the user sends one packet to a group of users in the LAN, not everybody. And Anycast, this is only true for IPv6 network, is when the user sends a packet and it has a special IP address, and whoever in the network has that special IP address gets it. Whoever gets it first wins. Anybody that has the address that I'm sending you can have it. That's what Anycast means. All right, I'm going to stop right here. We'll continue with this chapter on the next video. So write everything that I told you now. This is very important. And please upload that, and I'll see you on the next video.